Okay, we are going to continue with the mid-year exam for Set 3 Express 2015 paper. So in this video, we are going to go through question 8, 9, 13, 16 until question 18. So in the previous video, we went through question 2 and then I'm interrupted. So that is why you have a separate video now. Okay, so question 8. Okay, question 8 is about kinetic model of matter, and you are expected to know how the particle behaves when there's a temperature change. So if you look at this video, you look at this question, you see that pressure actually remain constant and that your temperature is being reduced. So upon reading that, you should be able to relate. So temperature is always related to the speed of molecule. So we know that when the temperature drops, it must reduce. Now for the rate of collision is a little bit more indirect. You need to deduce it. So let's look at the screen. So we know that pressure is given by force over area, and we know that this force has two components. Number one is the collision force. The other one is your collision frequency. So in this case, we know that your collision force is being affected by a drop in temperature. So when you have a drop in temperature, the speed decreases and hence your collision force will therefore decrease. Now, in order for the pressure to be constant, why is it that I say that pressure is constant? Because look here in the question, it says that pressure remain constant. The area is constant, so we know that there's no change here. So if we look at the force, when collision force decreases, in order to balance this decrease, the frequency of collision must increase, so that this increase in frequency would balance off this decreasing effect of the collision force. And hence, in your question, the rate of collision would actually be greater. Yep. So that is how it goes. So the trick here is that many students thought that when temperature lower, both the speed of molecule and the rate of collision will be affected. Now that is not true. The temperature only affects the speed of molecule. As for the rate of collision, which is also known as the frequency of collision, is actually affected by two things. Number one is the number of molecules. Number two is the volume. Okay, so do not have the assumption that temperature will also affect the rate of collision. Okay, let's look at number 9. Number 9. Oxygen is supplied to a fish tank of bubbles and all that. So again, it is about kinetic model of matter here. Now, what happens is that you need to have the basic understanding that when you have a tank of water, now when you are deep in the tank, so in this case, when you are deep, let's say you are here, you can see that when you are here, you are actually being compressed by this much of water above you. Compared to when you are near the surface, you are actually being compressed by a lesser amount of water. So because of that, we actually say that when you are deep in the water, you will face a higher external pressure. And when you are in shallow water, the external pressure is a little bit lower. And you have learned that if, let's say, you have a balloon, or in this case an air bubble, the size of the air bubble is determined by the external pressure and the internal pressure. So because of that, when you are at the deeper end of the water, when you are deeper in the water, the external pressure is higher. Therefore, your bubble will be small in size. Okay, and when you are at shallow water, your bubble will be bigger in size. Now, why is it that when you have an high external pressure, you will have a small volume? Now, remember just now in the discussion, we talked about pressure is equals to force over area, and this force has two components, the collision force and the collision frequency. Now, when the external pressure is high, the internal pressure must be as high, because then you will achieve equilibrium and your bubble will stay in that shape. Now, how do I achieve a high internal pressure? There are two ways. Number one, either you have a high collision frequency or you have a small surface area. Now, in order to achieve that, when your bubble becomes small, obviously, the bubble wall, when it is small, you will have a small area. So, because when your denominator is small, naturally, your pressure here will be high to balance off the high external pressure. Similarly, when you have a very small bubble, the collision frequency here will be high, and this will give rise to a high force, and therefore your internal pressure will also be high. That is the reason why when your external pressure is high, internal pressure is high, and therefore you need a small surface area and a high collision frequency. So because of that, when your bubbles start to rise, two things will happen. Because the external pressure is lower now, therefore your internal pressure will be lower as well. In order to lower this internal pressure, your surface area will increase and your collision frequency will decrease. And so, like what I said, the pressure will decrease as it rises because now you have a smaller volume of water pressing onto the bubble. And secondly, your volume will also increase because now with the lower external pressure, your internal pressure will be lower. And how can you lower the internal pressure? By either increasing the surface area, which is the size, and as a result, your collision frequency will also decrease, and hence your internal pressure will decrease. Okay, so that's how you solve this. Then after that, question 13. So let's move on to question 13. You are asked about the boiling point of the substance. Which of the factors affects the boiling point? So I'm quite disappointed that you are asking this question. The reason why is because this question is content based, meaning that if you have read your book while trying this question, you should be able to solve it. So go to your textbook and find out what are the factors and how it affects it. Whether increased atmospheric pressure will have an increased effect on the boiling point or the other way around. Okay, so this one I leave it to you. Go and find out for question 13. It is in the textbook. Okay, then question 16. Okay, question 16, it is an interesting question. I'm happy to help you to solve this. So in this case, you were given the object position and the image position. So remember, there are 5 rules to draw the ray diagram. So you know that whatever ray that emit out from the object must converge to the image point. So let's draw the 2 rays that we used to draw. The first ray will connect the tip of the object to the image of the object, and it should pass through the optical center. So when you draw this ray, even while drawing roughly, you will notice that this ray, the ray that is directly connecting them, must cut through the optical center of the lens. Now, having this content knowledge, then you would know that C must be your answer because it only cuts through the optical center here. Why is it that it won't be A? Because you can see that this ray cut across this point, which is not the optical center of lens A. Okay, so therefore it will be like that. Now, let's extend this question. What happens if my lens B is the correct lens. How will the image look like if I use lens B? Okay, so I'm changing the question a little bit. So let me erase this, erase this, erase this. So how would I draw that? Like I said, number one, the ray passing through the optical center will go straight. So I will draw a ray down here. It will be straight. Remember the arrow. Then I will draw a parallel ray to the principal axis. This is the principal axis, and it will cut the focal point. But in this case, since I do not know the focal point, I cannot solve this question. Okay, so if you are asking me what if the lens B is the correct answer, where will my image be? I can't answer you because I do not know where's the focal point. Why? Because when you have a light ray that is parallel to the principal axis and it cuts the lens, how it will move is that it will go to the focal point of the lens. So without the information, you cannot continue. Okay? Then question 17. Question 17 is about heat transfer. And for your heat transfer, you need to know that whether or not it is an emitter or radiator or absorber or reflector depends on the temperature of the object, not its color but its temperature. So once we see if you know this, you look at the question context. It says that it is hot. When an object is hot, you know that it cannot be an absorber because heat will move from hot temperature to low temperature. So it's like this guy is hot, the surrounding is cold. Can heat go this way? No, right? It cannot go this way. Okay, sorry, I draw better. Later you think that it is a cold energy. There's no such thing as cold energy. You would not expect a heat that will be going here because this itself is already hot. So you know that this two is wrong. So you know that your absorber cannot be the correct answer. It cannot absorb. Correct or not? Yeah, it cannot absorb. So in this case, let's look at the inner surface. The inner surface is in contact with the hot liquid, and so like I said just now, it cannot absorb. Okay, and you know that this question is about radiation, so again it cannot be conductor. Okay, there's nothing for it to conduct the heat away to because it is vacuum here. So even though the hot soup transfer the heat to the surface through conduction, the surface cannot pass on the heat to the next medium because there's a layer of vacuum in between. There's a layer of nothingness in between. So conduction cannot happen. Same thing because now I'm talking about C. So similarly for C, because your inner surface is in contact with the hot soup, meaning that it is at a higher temperature, it cannot be a reflector as well because the heat will not go pong like that, right? Correct? Because this guy is hot. So if it is hot, then the heat energy will be going out. It will not get absorbed or it will not get reflect or whatsoever. So therefore C is also out. So actually the only answer is your A. Now how about the outer surface? Now if you look at this diagram again, let me erase those that doesn't make sense. The outer layer of surface is right here, represented by the blue line. And you can see that this black color radiation, the heat radiation, is coming out from the hot object. So for the outer surface, it is actually playing a role of either an absorber, if not a reflector. Okay, because the heat will either be going into the surface, which is an absorber, or if not, it will get rebound and go back here like that. So the blue line here is playing a role of a reflector, if not an absorber. So that's why A is your answer. Okay, then your question 18. Question 18. Okay, for your question 18, go and look at the ray diagram of your textbook. Look at all those ray diagram. How do you solve this question is that you have to look at the image property. So the image property here, this one, it shows that it is dotted line. What does dotted line represent? virtual image, and there is only one ray diagram that will produce virtual image. And if you read your textbook, that only one configuration that give virtual image is when your object is in less than one focal length away from the lens. So therefore, the focal length of the lens must be B. Okay, so that the object is now within one focal length. What I mean by within one focal length, if this is F, then your object is within 1 F distance. And when your object is within 1 F distance, you will get a virtual image. So that is how you make use of the ray diagram in your textbook. Okay, so for the other question, feel free. You can always ask me through WhatsApp. Then I will either give you some hints on WhatsApp, or I will just post a video for you. Okay, good luck for your exams.